Hello there, it's Jay here from Jay's Vintage Junk, and today I thought we'd carry on having a look at the Apricot F series, well this Apricot F2. Now if you remember in the previous video we had a quick look at what I'd picked up, and we had a look at the keyboard and we ascertained we actually got the keyboard working okay, and we tested it using my Apricot Portable. So what I thought we'd do today is actually delve into the Apricot F2 itself. We're not just going to put power up this and see if it works. These things are getting a bit too rare and expensive for that. So what I thought we'd do is we'd pop the power supply out of it, because I'm pretty certain inside the power supply in here is one of them little Reefer brand capacitors that love to emit the magic smoke. I mean, it's not actually, that itself's not really going to do any harm. The most it can really do is like blow the fuse in the mains plug, possibly damage the main switch, which would be easy enough to replace. But we want to get that capacitor out of there anyway, because I don't particularly like the smell when them things go off. But once that's replaced, we can actually power the power supply up on the bench and actually make sure we've got some sensible voltages coming out of it. We can check some of the electrolytic capacitors. I don't think I'm going to go into a full recap on the PSU today. All I really want to do is make sure it's in a decent enough state that we can, I'm happy that it's not giving any nasty voltage out, so we can actually see if the rest of the Apricot works. And basically we can take it on from there. So, first thing we better do is actually open this thing up and see what's inside it, because I haven't actually had the back off this yet. I thought we'd save that and do it together. With these Apricot F series, incredibly easy to get in. You've got two screws on the back there. We take them out. This back panel comes off. The top lifts off, and that's basically it. You're in. So let's whiz these two screws out. This one. I have noticed this is the only part. I mean, yeah, it's horrendously yellowed, but this is the only damaged part on the case is this back cover here. You can see there, it's got a couple of chunks broken out of it. I might have a go at repairing that. I don't know how successful I'm going to be, because it's very thin plastic, but I may have a go at repairing that. If not, I have spotted these every now and again on eBay, and people want about £20 for them or so, just for that bit of black back plastic. But if there is a mint one, I don't know, I might get a perfect one. It depends whether I can clean the rest of this case up to a decent degree or not. Right now, yeah, just lift up. I thought it might give you a, oh right, well you can't see very much, but that's how you get the top of it. It is literally just a little lift like that, and it comes straight off. That's handy. We'll put those out of harm's way for now. And here, right, so we've got the power supply unit there. I presume that's like the disk drive cage. We'll get the power supply out, because I think we'll probably work on that on the workbench. Let's try taking this out. I'm not 100% sure how this power supply actually does come out. That removes it from the back, does it? A couple of screws on the side. Screw there. That's interesting. So we had a machine screw into a little brass insert at the back there. And the next screw down's a plastic screw straight into the plastic. Right, let's have a look round here. That I believe is the RAM expansion. Better stick some anti-static precautions on if we're going to be handling that. But I wonder if we pull that out just for safety, just for the moment. So, I presume this is the RAM expansion. Right. So we've got 512k. So we've got a half meg RAM expansion there. I still can't quite see how the power supply comes out. It's loose on that, so let's try taking some more screws out. I think you might have to take this cage out actually. Let's start taking some more screws. In fact, I don't want to just leave that, I just don't want to leave that just lying on the desk like that, so I've got an anti-static bag here. We'll stick it out, in fact I'll just wrap it like that, just to keep it out of harm's way for the time being. So that'll be going back in obviously, but at least it's not going to get damaged while we mess with this. Let's take, I think we're going to have to take this this metal cage out just to be able to get the power supply out. We shall see. Take that out. At least it'll give us a good view of the main board if we do that anyway. I'm going to take that screw out. Right. Oh, it's looking more... Every time I take another screw out it seems to get a little bit looser, so hopefully we're on the right track. Screw out there. I think there's only one more really, which is this one. In fact, it's probably as well we take this metal cage out. Anyway, because we're going to have to be able to disconnect the power supply from the disk drives, and they're under that. So hopefully, that just lifts out now. There we go. Ooh. Looks like we've had something. Looks like bits of cement or something. It did say it was stored in an attic, this, and it looks like there may have been a leak. There's a little bit of corrosion, if you can see, on the top of the lid there. And there's some little bits of, I don't know, looks like cement. Let's see if I can get it off there. I don't know if you can make that out in between my fingers, but it's mortar. So I think this really did spend many years in an attic. Perhaps we will have to look a little more in depth at the disk drives. Right, that's free. Oh, and it doesn't look like we do have to get to the disk drives. It does mean those disk drives are horrifically non-standard, but that shouldn't be a problem. It looks like everything runs through the main board, so all we have to do is just remove this one connector here. So let's pull that free. It's definitely not like a PC power supply. It's a lot more simple than that. Right, so that's free from there, and we can lift the whole power supply out. So that's our power supply section there. In fact, that seems to be bolted onto like a subframe. Yeah. So I'm betting if I undo these screws here, this is another part will come off. But you do have to basically take the entire system apart just to be able to get the power supply out. The board actually looks incredibly clean. I'll get you over and give you a decent look at the board in a minute. But it does look really nice and clean. Doesn't look like there's any nasty corrosion anywhere really. It looks pretty good. There's a few electrolytic caps on there which I'm sure will need at least testing. They'll probably need replacing. Fortunately it's of an age where there's none of them nasty surface mount electrolytics we find in slightly later equipment. All we've got are some axial through-hole electrolytic capacitors on the board. So I'm pretty certain for longevity most of them will probably need replacing, but at least we'll test them out. The most important thing at the moment that we want to check out is basically the main supply here. So what we'll do is I'll pause here and we'll go and we'll set up on the bench, and we'll just do a quick once over of this power supply, make sure we're happy with it before we put it back in this thing and actually give it a first test and see if we've actually got any life in the system. So back in a sec. Okay, we're over on the bench. We have the power supply. What I have found out, I didn't spot this before, it actually tells us what this should be outputting. So we've got pin 7, 5 volts at 3.75 amps, so nearly 4 amps. Then we've got a common pin, ground basically. Then we've got plus 12 volts at 1.5 amps. Then we've got again another common, and then we've got a minus 12 volts at 0.4 amps, so 400 milliamps. Made by Aztec, which I was pretty sure of. This is interesting though. It's made by Aztec, which I believe is a Japanese or Taiwanese or one of the Far Eastern company. But this is made in Great Britain by BSR Manufacturing Limited. Now, I don't know if many of you know BSR, but BSR were famous for making record decks, auto-changing record decks in the 60s and 70s. I didn't know that they had some dealings with Aztec, so they obviously used to put Aztec's power supplies together for them over here in the UK. That's interesting. You learn something new every day. Anyway, let's get inside this thing and we can have a look, see how it's put together. With it being an Aztec supply, I'm pretty confident it's actually going to be fairly decent. Aztec, generally speaking, made good quality power supplies. I mean, you do have issues with them now, but that's purely due to the age of them. They were fairly, they were good supplies in their day. There we go, we're in. And that is, now where have we seen that before? That to me looks very, very, very much like the power supply as used in a BBC Micro. We'll disconnect this so we can get in there a little bit closer. But that looks very, very much like the power supply used in a BBC Micro, which of course also is made by Aztec. And actually, thinking about it, probably, jeez, they've done that uptight. Let's try plan B. Plan B would be to disconnect it from here instead. That does look very, very, very much like a BBC Micro power supply. It's a pity I haven't got one lying around here actually to compare it with. Let's take that off there. Try not to lose any of the star washers or anything. Right. We're in a little bit further, we can get that out of the way. Yeah, it does look like a BBC supply, that. Or at least very, very, very similar to one. Which would make sense, like I said, because I think the supply voltages we're talking about generating for this are basically what a BBC uses as well. Be interesting to see what the serial number, what the model number on the board is, and then reference that to a BBC one. Right, we can unplug that there. I mean, it's not obviously it's not going to be identical because, like I said, the BBC one doesn't have like an edge connector on it like that. It's the wires are all just wired in, but it does look very, very similar to it. Let's get a bit further in here. Right. Yeah, of course, that's the pass-through. When I said we've got plus 5 volts ground, plus 12 volts ground, minus 12 volts, and then those two blue wires there are the AC voltage from the external power supply, and I think they will just go straight to driving the monitor. We don't really need to worry about them too much. That's something completely different. It doesn't actually have anything to do with this part of the power supply at all. Let's get that cable tie off there so we can get these apart and pull these off the switch. I just have to help them off. That's the first one off. There's that one off. And hopefully we can get the board out of the case now. We can have a proper look at it. Yeah, because there's a connector there that I believe would be used when this if this was used in a bit. I'm certain this is the same as a BBC. That wasn't tight. And a screw there, and it weren't even done up properly. And that one wasn't tight either. We don't like loose screws in a power supply because, you know, they can work even looser, and eventually they're going to come out. You've got mains voltage floating around in here, and that's never going to end well. So when you work, you know, you make sure your screws are nice and tight. Take them off and put them to one side. That's not the same as on a beep supply, but there we go. That's free. Let's have a look. What else is holding? Come on, out you come. That's free. Come on, out you come. There's something in that corner there that's preventing it. Let me just see if we can get that screw out. There we are. Now are you going to come out? There we are. Now we are. What's preventing us to coming out now? That earth there. Let's connect that. And we should be free. There we go. We're free. We'll put that little spacer to one side. And now we've got that spacer out of the way, that does look, basically, I'm pretty certain that's exactly the same as a BBC one. In which case we know exactly. Now that's interesting. Those don't look too bad. We'll give this a smell test shortly. But that is interesting. Now I believe that little electrolytic down there will be to do with the start circuit. Basically what you have is you have a really simple power supply built in the start of these switch mode power supplies, which actually kicks the power supply into operation. And one of the really common faults with these is that electrolytic dries up, and it actually prevents the entire power supply from starting up. Now, I've never seen it before, but that seems to have been it's been encased in like a heat shrink. Now, I wonder if that's been done because that was a really common failure, and they've actually done that to give it some insulation to perhaps stop it getting so hot, being that it's really close to the big power switching transistor there. Yeah, I've never seen it done quite like that before. That there is the reason we're in here. That is one of these reefer band capacitors, and in fact we'll whip that straight out of circuit. We'll get that right out of here now, and we can take a proper a closer look at it. But these things are basically, they're straight across the mains, and they are renowned for failing, and they stink up your room when they go. They aren't going to cause any major hassles when they go, but they stink. I think we're free there. Come on, out you come. There he is. It's actually not in horrendous condition, that one. It is just starting to crack up. I don't know if you can make it out, but it is just starting to crack that. But I bet if I was to play with it, the case would start breaking bits off. It's got a few hairline cracks in it yet. And being this thing's been stored in a attic, then we don't want to really risk it. I've just realised I didn't actually go out and pull any spares out, so I'm just going to pause the video while I go and get a replacement for this, and then we'll be right back. Well, that was a fruitless half an hour of searching. It looks like I've completely exhausted my supply of replacement capacitors. It's a 0.01 UF X-type capacitor. Fortunately, thank goodness for e-waste. I've got a scrap board here out of an old LCD TV. Unfortunately, it uses exactly the right filter. So we'll whip this off here. Even though this is a reclaimed part, these type don't suffer from the same problems as these older reefer branded ones. So even though this is a reclaimed part, it's not going to be a problem. We'll just whip that off there. Come on. Us. We'll get him off there. Come on, off you come. Hasn't quite got all the solder off that connection there. A bit of a ground plane on it, so it's being a bit of a pain. Get a bit of fresh solder on that should get it out. Sometimes when you're struggling with the connection, it's adding a little bit of fresh solder. There you go. That's all that's needed. Put that back in the e-waste pile. And we have a nice usable capacitor. What brand's that? Can't actually see a brand on it. But it matters, it'll do the job just nicely. Stick that in there. There we go, that's in. And just solder it in place. There we go. Solder that in like that. There we are, that's it. There we go. That's our new capacitor in place. Now, I'm not actually going to change that one straight away. We'll try the power supply first. Purely because it's got that heat shrink on it, and I think it's probably going to be okay. I'm not even going to change these straight away. I probably will actually just mark down what these are, and I will get new capacitors for these, and I will swap all these out. Those are probably going to be absolutely fine. They've actually very rarely failed the two main smoothers there. They're the high voltage smoothers, and so 9 times out of 10 those are fine. These are usually not too bad. I'm speaking here about BBC supplies, but looking at it from a first glance, I'm pretty certain this is basically a BBC power supply, that they just use the same basic design. What I'm going to do though is I'm going to have a quick smell test just round the capacitors. What I mean by that, and you've seen me do this before, just take a hot soldering iron and we just run it near the board round where the capacitors are, and we just have a bit of a smell. And what you try to smell is like a fishy smell, which is a dead indicator that there's been a capacitor leaking in that area. I mean, I'm not getting any fishy smell come off. It doesn't mean that these capacitors are perfect, but it means that they're certainly not leaking a load of electrolyte, which makes it me a little bit more confident about actually firing this power supply up. We'll just shut the desolder station off because we don't need that running. Well, we could just connect that up and test it. I think we will reassemble the power supply, because we do have to be mindful. You know, I've been working on these for, well, since I was probably far too young to be working on things like this, to be fair. Some people are just getting into this, and you know, they need to still learn to respect mains voltage and working on this old equipment. Just make sure we get this to sit back where it should sit. There it is. There's a screw in there. Just try and get the little washer, there we go, into position underneath the screw. Look at that. And there's just 3 screws holding the board down. That's one. Got one down here. So we'll probably be taking all this back apart again, but for the time being, we'll put it back together for testing. That's that. Put the earth back on there. Put that back on there. Oh, we've got that heatsink to go back in as well. We'll slide that back there. It's just like, basically it's just a spacer by the look of it. So it transfers the heat from the internal heatsink to the side of the case. Just helps draw some more heat out of the power supply, basically. So we'll screw that back in. We can reconnect. Make sure we've got that the right way around. Yeah, I think it's that way around, by the look of it. Reconnect that there. Well, we'll know that because if we get voltages in the wrong places, then we know we've got it wrong. But I think we should be okay there. That's looking good. Now the bottom one was the positive. No, sorry, the bottom one was the live, not the positive. Like that. Push that home. Obviously this is slightly different to a BBC. Push the neutral on top. There we go. So that's all back together. Where's the lid? Might as well refit the lid. Spin that round like that. That sits there. Put my fixing on there. The washer on. The nut on. And make sure you put this down nice and tight because it is your safety. There we go. So we'll tighten that down. There we go, that's nice and tight. Close the power supply again. A couple little tabs there, push them in. And then 2 screws to secure it. And one there. Okay, there we go. Suppose the thing we better do now is actually test it, make sure that this thing is actually okay. Let's make sure that that's in the off position there. Now I've got an IEC. Oops. I can just borrow this one that's used for my test monitor. Oops. I think it'll pull out far enough. No, it won't. Just bear with me a sec, folks. I've just got to see if I can find a IEC lead that we can test this thing with. Ah, there. I knew I was going to kick it about. Where's the other end of that one? Come on, where have you gone? There we are. We've got an IEC lead here. Just to make sure we have got a fuse in it. We don't want to be chasing our tail. Yep, there's a fuse in there. Right. I will plug that in. That's plugged into my bench. We'll plug that in. I've not got it switched on at the bench yet though. So we'll switch on there. We'll get the old multi-tester out. Can you see the display on that okay? I have to just prop it up slightly. Some tape here. Right, now can you see that display alright? Apart from our test leads being in the way. Right, there we go. Now we've got that set okay. We'll connect this up to the 5 volts input on the PSU like that. And switch on. And we'll switch on the power supply and we'll see what voltage we get on there. So that's the power supply on. Remember this is off load as well, so we've got 5.16. So 5.16 off load, that's not bad. I'll just quickly switch off again. We will, and you see that's dying away. So at least that it shows that the output capacitors are fairly healthy. Right, now let's try the next one. This should be 12 volts if I'm correct. So let's switch that on there. 11.69. So we're a little bit low there, but again, we're not too bad. I'm reasonably happy with that. let's try the next. Well, the next we've got another ground, and then we've got, this should be minus 12 volts. So let's see what we get here. There again, minus 11.3, 11.2. We're a little bit on the low side, but again, not terrible, not terribly. We certainly will change all the caps in this power supply, but that's okay. It'll do for testing. We've got reasonable, sensible voltages there. So yeah, I'm happy to actually plug this power supply actually into the Apricot. We'll get this connected back up in the Apricot, and we'll actually do some testing, see what the Apricot actually does. I won't bother filming me putting this all back in the Apricot, because that'll just make this video a little bit too long. So join me in a second. I'll have this put back in, and we'll see if the actual Apricot's going to fire up or not. So join me back in a sec. Okay, we're back, and as you can see, basically I've got the power supply put back in the computer. I haven't bothered putting any of the shielding back on. I've not bothered putting the RAM expansion back in. So this is basically in its minimum configuration, and we might as well give it a try. What I've done, I've connected a composite lay cable up to my test monitor here. So we'll try it on composite first and see if we can get any output off it on composite. So I'll plug that in the back of the computer. Where's my remote control, and I can then set the set that onto its composite input. There it is. Right, let's see here. AV1. I think that's the external composite there. Is either AV1 or AV2. We'll see in a minute. Anyway, I've got an AC lead here, so we'll put some power up it. There we go. Pull that back a bit. Put that up. Now, what can I unplug? I suppose I can unplug my anti-static strap, because I'm not using that at the moment. And we can always touch the metalwork to ground ourselves. So that's the computer plugged in. Right, what else do we need? It'd be handy if it does do anything if we've got the keyboard. Now, what I might do, I might just give the keyboard a try with the actual batteries in it again. So it didn't seem to work with the batteries last time, but it did work when I used my little adapter. But we'll give the I did check the batteries, and I was getting decent voltage out of them. So just try and get this damn thing up again on the keyboard. Just bear with me a sec. We'll give this a try again. Plug the battery pack in. If it doesn't work, it just gives us something else to troubleshoot, doesn't it? But so we've got a keyboard, basically, just in case. I'll push that back a touch. Then we can get the keyboard in front. If you've seen my previous video on this computer, the keyboard's actually wireless to the computer, so hence why it has the batteries in it. I've got my box of Apricot F series software here, so if it does do anything, we can at least try. So let's switch on and see what happens. So we've got the power on. So our power on lights come on. We just try switching the video over onto the other AV channel. There we go. So it does appear to be working. Now that's interesting. Now why is it telling us we've got 1001? That's like 1.44 meg. These are at 1.44. Ah! Right, they're 720k each. So is it classing them both? So we've got 1.44 meg of disk storage basically. We've got half a meg of RAM. Time and date isn't set at the moment. We'll worry about that later. Let us see if it can actually boot some software. But the computer does actually seem to work. I've got my Apricot portable boot disc that I showed you in the previous video. It's only got command.com on basically, but it will see if the computer actually is going to do something. I'll put that in drive A. Look at that. And the keyboard's working. Excellent. Also, there's quite a bit of noise coming from that power supply. More than I'd normally expect. I am keeping my eye on the power supply as we are working here. Let's try. What can we try? We could try and see if Gem will run. I don't know whether it will, but we can give it a try. Because basically you have to configure Gem. But let's have a go. Try putting the Gem disk in. And reset. Let's see if reset works. Reset actually works on this one. Reset doesn't work on my portable. Right, let's see if it'll find the disk. Yep. Right. Obviously, I mean, this is Gem Desktop. It obviously doesn't like the graphics mode. Perhaps it's more that. Perhaps that will only work with the monitor. Let's take that disc out. There's a chance that that is only going to work with the monitor. Let's see if we can load a game. Anyway, I'll actually show you that zombies I was showing you on the previous video, and you can see possibly what it looks like on a proper screen. Right, there we go. In fact, let's we'll leave that in drive A, and we'll put the games disc in drive B, and it gives us a good way just to test to see whether your drive B is actually working. I mean, we will pull these drives out and give them a clean and a proper going over, but that, like I said, that'll be in a separate video. I'm just really want to see, you know, obviously we've seen that the power supply is at least good enough to get the computer working. Just basically see what is actually operating on it in this video, and then we can take each individual part as it is and do a full refurbishment on each individual part. Anyway, let's see if drive B is going to recognise. No. Excellent. Fantastic. Right, let's try see if zombies will run. No, because I've played this game before. We've seen how crisp the graphics are. I mean, this almost looks like VGA quality. I mean, it's not like your standard composite. They use their own video standard. These Apricots. And it's really, really nice, that text. It does look like we only have black and white through the composite output, though. Like I said, these things are colour capable, but it's obviously just through one of the Apricot monitors, that, unfortunately. Let's put 3. Oh well, never. I didn't even get one. First line went straight down a pit then. Yeah, nil point. Another game, no. Let's see what else we've got on this disc. Just as a quick one, and then we'll finish this video anyway. Let's try dot. I wonder if you can turn that click off. It is sort of slightly annoying, that, especially since it's a reasonably clicky keyboard as it is. We've got Snake on here. Let's see about running Snake. Let's see if this is going to run. Again, I think we may have a graphics issue here. This probably needs a higher resolution monitor. I presume it'll run with the Apricot monitor, but we'll get to that. I'll say it in a later video, because we not only do we have the monitor that came with this computer, we also have the new old stock monitor which I got from my Apricot XI. So in fact, it would make a good computer for testing monitors. Now we know it actually does work, and we can at least see whether both my Apricot monitors do actually work. Because one of them, I think we're going to have to do some repair work, or at least some assessment of. It's got a little bit of physical damage on it, and it doesn't seem to have the right CRT in there. But we can at least see, try and see what it's going to do. But the Apricot F2 actually works. The disk drives appear to work. The computer appears to work. Obviously it's going to need recapping. Like I said, we'll do some servicing on the disk drives and what have you. But I am super pleased with this. I'm going to leave it there for now. Like I said, in the next video I think we might have a quick look at the monitors, the actual proper Apricot monitors. See whether they work, see if they're going to need any major repair or not. Because even the new old stock one I got, I don't know whether it works. It's been sat in storage for many years. But I said, this definitely we are going to do a full recap on the power supply, and I probably will do a recap on the main board as well, just considering how old the electrolytics are on there. The same age as, well, not much, well, yeah, same age really as what you'd find in the early Spectrums, and if you've ever worked on them capacitors are starting to fail now. I don't want to have any issues on this board, so we might as well change them. So the power supply certainly does look like it is basically the same as is in a BBC Micro. It looks very similar. I might even, when I do the recap on it, I might even pull out a BBC Micro, a spare BBC Micro PSU, and we can put the two side by side and actually see exactly how similar they are, or if they might even be identical. I'm not 100% sure yet. Anyway, I'm going to leave it there for now. I hope you enjoyed this little update on the Apricot project. So thanks for watching, and goodbye.